Welcome, everyone, to our series where we talk about the building ontologies with basic formal ontology. I'm Ian.
Hi, I'm Obi.
Yeah. And today we're going to be talking about chapter six, which is Introduction to Basic Formal Ontology 2. And we'll be talking about occurrence today, which is the other main split between entities. So the very
Hmm.
first one is a process. And this is one of the main categories in occurrence. And a process is something that happens rather than something that exists. So this is that split between occurrence and continuance, where continuance are things that continue through time, and process is something that happens in time rather than something that simply exists. So an example might be like a fire burning. We can think about the logs; those would be continuance, but the actual burning process is going to be an occurrent, and that will be a process because it unfolds over time. It has a beginning, it has a middle, and it has an end. Um,
Ah, Occurrence. I do love this part two because it kind of breaks things and puts things into place. We've got cases where the ontology will say deploy it as a server and also say incident is a document and authentication is a person. And this is one of those classic things where some models happen like there are things, and that's why this chapter says occurrence, because of the BFO split reality into like two big words, like the continuous and the occurrence, like things that we ensure, which we learned last week, and occurrence things that happen or process that unfold over time. Our earlier chapter, we cleaned up how the noun is used. Now we're going to clean up how the verb word is used.
so the last thing that I'll say about processes is that processes happen and they depend on things to happen. And they're made up of intervals of time. So there is a dependency relationship between processes and continuance. Um, And then the next breakdown is in history. And so every material thing has exactly one history. There is one history for every object and one object for every history. And it's the sum total of every process that has ever occurred within the space that that thing occupied. So that's at every level of detail. Adam's history is not just the story that you tell about him at his retirement party. This is like everything that happened to Adam throughout his life. It is like every heartbeat, every cell division, every neutrino that passes through Adam's body. So most of it's never recorded or even noticed, but it's still part of his history.
You just said time and happening, and this introduces the occurrence time side of BFO, which we do process boundary, temporal region, and spatial temporal region. It gives us a crucial alignment rule, right? Objects are located in spatial regions, process are located in spatial temporal regions. I will give an example. A tumor is where in space? And surgery is where and when in space-time. So you can now see how it affects how the process connects to the continuum via a particular, like two big objects participating in collision. A patient participating in a surgery gives us this broader sense.
Yeah, and specifically what Obi is referring to there is the spatiotemporal region. So we have the temporal region in the current side of BFO. We also have the spatial region, sites and boundaries on the continuant side of BFO. But the spatiotemporal region is actually a really specific place. It's the chunk of space and time that a process occupies. So it's not just where it happened, but it's where and when. So like if you're talking about the surgery that Obi's talking about, it could have happened between 2 and 4 p.m. in an operating room, for example. Um, but the temporal region would just be that like last Tuesday between 2 and 4 p.m. So that's only the when, not the where.
That is true. I think now I'm going to dial it back a little to like do some occurrence definition, like what is an occurrence? An occurrence is something that unfolds through time. It's a temporal extension that has duration. So a surgery, a meeting, this is an occurrence. Uh, our classes is an occurrence. A chemical reaction is an occurrence. For me, a deployment is an occurrence. A database migration is occurrence. The NASA just launched rockets into space recently. That's an occurrence. um, so we see the server as a continuous and server rebooting as an occurrence. And right, most of the important disciplines don't treat occurrence like a material entity. If it happens, it's not a thing that you can store in a closet, right? Occurrence on a high level will be on the highest level would we have like a process that unfold happening. We have a process boundary where the start and the end of the boundary of a process take place. Then we have the temporary region where the interval slash time point where the process occurs. And then we have like the spatial temporal region, the region space-time the process occurs. Think of it like a film. The process is the movie, the temporal region is the runtime, the spatial temporal region is the region of the runtime plus the stage where it is played out. The process boundary is the frame where it start and stop.
Yeah, that's a super helpful example. I love that. Um, I think the only other thing that I would want to add that the chapter talks about is the zero-dimensional temporal regions and the one-dimensional temporal regions. And Obi just referred to that with the start frame and the stop frame of the movie, for example. That's going to be the zero-dimensional temporal region. So it's like an instant in time. If we think about a line, we have like a one-dimensional temporal region. So that's the time that the movie runs. And then we have the zero-dimensional, the points on each side, which are going to be the process boundaries. Um, yeah. And they work together in the same way that like the line segment works in geometry. So the line itself is going to be, it's just one dimension, it has length, and then its two endpoints are zero dimensional. And those are like pure points, zero length, one frame. The interval is the stretch, the instant is like the end caps.
Yeah. So I think what I would break down now is like the start of the occurrence side. The process unfold through time. It has a face, it has a path, and it has a temporal structure. And it's not optional. If you have a domain has changed workflow, behavior, and event, you need to process the modeling. So, just like a example I always go to would be like in medicine, surgery would be one, and like DevOps, incident response would be one. In manufacturing, assembly would be a good example. In data engineering, running your ETL pipeline would be an example. And my favorite, which is just like after looking at a lot of NASA launches, what's going on this week would be the launch sequence, right? The countdown and things that are happening. You can see how those processes are related to object via participation. That I would like to talk about the process part and the process profile. It's another thing I would like to talk about before we finish today. Like there are a few things I want to like touch on. Participation is the bridge, right? The object stays as an object, but it can get involved in the process. So a surgeon participates in a surgery, a patient participates, a patient participates in an exam, the server participates in a failover, right? So you can see there's a bridge. There's a bridge for it to happen. Like the surgeon participates in surgery, that you can see the participation happening, and if you translate it that way, it gives you a continuous that touches time because it's participating. You can say the surgeon did the surgery from 2 a.m. to 4 a.m. He participated in that surgery. This where a lot of modeling become clean. Like you're telling the word stay stable, you're happening the word explains the change, and your relation connecting them without any confusion. Because when people build ontology, this is the meat of the ontology, is where you have that stable ontology to be able to hand to somebody else. The other part that I will touch will be like the process part, the process profile. This is what I call like the realism, where like the first 5 minutes of a meeting, the warm-up phase of an engine ignition, or the triage of a incident report, right? This is where like you don't model incident or a single blob node. This incident phase just detect, you assess that, then you mitigate, then you recover, then you have a post-mortem. They're just like process part that you have to do. It's like if I'm going in for surgery, they might tell me 24 hours before surgery, don't eat. They might give medication to prep. When I get there, I have to check in. Then I might go through some form fill out. They might ask me who is your contact when you're done, and then I might go in for the surgery. The surgeon would participate in the surgery, and then I will be out on the other end, and then I will be discharged, right? So there's like steps that you come into that you have to think into while going through the process part and the process profile. This helps you because when you are able to do the process through, when you're not designing, when you're answering questions with your ontology, you can see where this falls into your ontology. Last that I would touch on will be um, temporal region. The reason why I want to touch about on this part is because temporal region is an interval, is a time interval, right? It's a time point which process occurs. The reason this is really stressful is the when itself, because a lot of people, when they build ontology, they don't, when they go to temporary region, things get hazy. And if you don't kind of specify it clearly, then you might come up with like your reasoning might be messed up. And this is the part where when you start doing reasoning, if you flush this out very well, your reasoning will be perfectly fine. Boundaries, right? It starts at like the surgery started at 9 and ended at 10 p.m. Start at 9 a.m. and at 10 p.m. That boundary itself would help you. So like those constraints help you clarify things. And sometimes this is not something you know because you don't know when that will happen, right? So it, depending on what kind of data you're working with, this is always crucial to know how to like plan to attack that temporal region.
Okay.
The process profile is how it's going.
Yeah.
You don't is a pattern like process over time. But especially when you care to measure things like rates, I believe, intensity, the level and the trajectory, rather than just the process happening.
Okay.
When the process, the way I will explain it is that when the process of folding through time, right, in the temporal region, the process profile picks out the pattern of some features that process as it unfold, right? Like the speed of the during the race, like the CPU usage during like deployment, the plane level, the patient level during recovery, right? Um, it's very useful when you want to model things that like has phases, right? If you want to measure something that has phases, this is very good to use. If you want to measure something that has a peak that spikes, this is very great to use. If you want to you measure something that has a steady state change, this is something that's very good, or a rate of change, or a comparison, right? It's not used for everything, but I think this covers it, right? The key intuition to me is the process, is the things that's happening, and then the profile is the shape of the aspect of what's happening over time, like the loudness, like the blood pressure. That part is where it becomes very clear why you're using this. The example is running. So for us to start the process profile, we'll have the stats, right? When he started running is when the process profile will start, right? Now we would say start. The profile will start. And then you said he started running at say he started running 0 to 2 minutes, right? During that time, his start surge started. Like he started going up. And then you said he started running at what speed again? 5 miles an hour. Would not
Mhm.
have that as like the stabilized speed that he's running at, right? So we'll call that like say his baseline speed that he's running, right? And then if he goes up, right, from there, say you give an example that he went up to like he's running faster. I cannot say he increased his speed and say at from 25 minutes to like 35 minutes, like he ramped up And then maybe at like 42 minutes while he was still running, fatigue happened and he dipped down, right? So, and then at the end, um, and at 50 minutes, he ended the race, right? That is the profile.
The whole thing.
Yes,
Okay.
that is the profile. So now we have like he started, right? He
Mhm.
spiked, which is he started. He was steady. He accelerated. He dipped, and then he finished, which is he stopped. That
Mhm.
is the process profile.
Gotcha. And so when we talk about the speed, we do talk about instantiating a certain speed at different times, but the whole thing is the process profile.
Yes.
Okay.
It's just
Fair.
when you start modeling stuff that has to do with things that move,
Yeah.
this becomes a very thing that you would face.
Mhm.
So yeah.
Okay. Awesome. Thanks everyone for listening. We'll be back and we'll talk about next week the relationships in BFO.
Thank you. Have a good one.
Thanks.
Bye. Bye.